Good morning all. I'm having a think about 2017 and the sort of projects that I'm going to be working on this coming year. Now, high on my priority list are the microcontroller tutorials, which I'm very keen to do, and I want to get started on those really as early in the year as I can. So here are a couple of these PIC boards. This is the one, this one is the one I've been using. But there's still this problem with the connector here, which I had to replace, and that's not particularly easy. It's too close to the power connector, and I have been using it recently with a PIC kit, but I'll show you what the problem is. So when you've got this board powered up, and you've got the 5 volts plugged into here, this is a USB to 2.1mm connector. It's actually not possible. This has to go on upside down, which I think is really naff. And it's not possible to get that plugged in because they're just all in line with each other. It's really crazy, and I have been bodging it of late by putting on this extender connector, sort of tipping it round at as much of an angle as I can and connecting it like that, but it's just a bodge. And you really want it to be connected like this because the PIC kit 2 and the PIC kit 3 have the ability to sense whether the target board has power on it, and if it does, it won't supply power. If it senses that there's no power on here, then the programmer supplies power to the chip in order to program it. It's very clever, but why have they designed it so that it doesn't fit? So one solution for the unmodified board is to plug in a 6-pin JST connector in there and then terminate that in a 6-pin header, put nice bits of heat shrink on here, and then you can put the reversal in by twisting the connector so that the program is at least the right way up, so you can see what it's doing. It's got 3 LEDs there. Alternatively, and this was a suggestion from a viewer, unfortunately I can't find a reference to that comment now. I've searched, I can't find it. Was to put a connector on the underside. Now he'd glued his in and he'd wired it up to the 6 pins up here. I've chosen to wire it more directly to the chip itself, and I've put mine on with double-sided a sticky pad, but it's fairly rigid because I've connected the ground pin down onto the back plane with a huge blob of solder, so that's really well anchored. That's not going anywhere. That's not quite complete yet, but that's an alternative to this connector. So there are a few things prepping this board before it's ready for the microcontroller tutorials. Now look at this. It's another one, except that it's not actually. Now this has just been sent to me by icstation.com, so thanks very much to them for supplying this. It does look very similar, but this is AT Tiny. So as well as machine code programming the PIC, I also want to embrace machine code or assembly language programming on the AVR core microcontroller, an AT Tiny in this case, or an AT Mega. Now these are clearly from the same designer, or someone's copying someone else. I'm not quite sure what it is, but this one comes with a strange 10-pin in-system programmer header, ISP or ICSP header. Now of course I've seen this 10-pin header before, so this is a USB ASP programmer for Atmel, and this comes with a 10-pin connector. Let's actually unravel this. So you get a 10-pin connector, but a lot of the pins on here are just grounds. There must be some history here, and I don't really know much about AVR. I know a lot more about PIC, quite frankly. But they've got this 10-pin connector, and then what happens is that you can get these 10 to 6-pin converters, because a lot of it's done 6-pin now, so I don't quite know why they put the 10-pin header on here. Here's a USB Tiny ISP, and it is a very small one, and that's only got the 6-pin. You can see the markings there, so that's not going to be any good for this unless you can get an adapter that goes the other way, but this clearly isn't it, because that's a 6-pin female, I suppose that is, to 10-pin male, so that's not going to work as an adapter from 6-pin programmer to 10-pin, so there are some issues to sort out here as well. And what intrigues me about this is that now that Microchip have bought Atmel, Well, PICs and AVRs are all under the same roof. They're all controlled now by one company. So how is this going to affect Arduino? Is Microchip going to put more emphasis on PIC or more emphasis on AVR? Is AVR going to disappear or be changed in some way? It's very interesting times. Now, another thing I want to do more of this coming year is kit builds from the ultra simple, like this electronic doorbell. Not quite sure why I cut the speaker off that. I think I wanted to use it for something else. So I'm just warming up the soldering iron, and today I'm using the green sponge with the round hole. So I'll solder that back on there. But yes, I want to do more kits, like simple stuff like this. Just a board. I think this one had the Happy Birthday song that it played. Oh, that's right. There had to be a mod on there because they'd done something weird with... oh, I can't even remember what it was, but I had to put a resistor in there. That's right. I don't think they had a base resistor to drive a transistor, and it was kind of latching up or something. So nice simple kit builds like that. The Christmas tree kit, more LEDs. Never got around to building that because of my own Christmas decoration, which kept me up very late a couple of nights. Let's move that out of the way a bit. Also things like this. This was the little walkie-talkie kit. I've soldered an antenna on there. So that was one of them. The other one is still in its packet, never opened. So I want to finish kits like that. And taking these kits right up to the most sophisticated. Here's a little sneak preview of something Banggood have sent in. Thank you very much to Banggood for sending this in. This is a JYE Tech DSO, so that's a digital storage oscilloscope. It's the 15001. Okay, let's have a quick look inside there. This is a liquid crystal display scope. Can I take that out? What about, no, I think the boards are all in here, yeah. So it's an LCD, and you get an analog board and a digital board. Oops, that needs to be stuck on there. It's interesting they don't stick that on there. I'm just wondering whether it's all soldered. I'm just wondering whether they do this so that if you stick it on all cockeyed, you've only got yourself to blame. The digital stuff's on here, microprocessor, microcontroller, and so on. So it'll be very interesting to have a look at this. So I've loaded up my eBay shopping cart with all manner of crazy kits: clap, switch, FM transmitter, an ammeter, sensor switch, something or other, ghastly looking microphone which transmits on FM, that should be fun, sound effects kit, some sort of robot, temperature sensor, things with LEDs, a wristwatch with an LED display, that should be fun, RGB lights with a huge microcontroller. What else have we got? Digital electronic clock, a simple amplifier, not sure what that is, voltmeter that you build yourself. Oh, and those things are not for view just at this moment. Right, so let's pull these wires out. Just no idea why I cut these. I must get some solder braid as well, because I'm going to have to solder suck those, and solder suckers are nasty. So you want to see it warts and all? Well, here we go then. Let's suck these holes. It's just so aggressive and does damage to the pads on the board. Oh well. Right, tin these two wires for putting them in the board. Oh look, that's good. The insulation has shrunk back, which is what I hoped would happen. Slightly tricky this, holding the wires while I solder them. Get in there. Good, right, that kit's built again. Yeah, I just feel with these really simple kits, they're so simple that you can actually get to understand how the circuit works in some detail, and I'll be drawing schematics and stuff within the space of one video. Of course, that's the other thing I want to do this year. I want to try and cut the time of my videos down a little bit. I want to try and produce shorter videos generally. Right, let's see if this works. Oh, that's beautiful, isn't it? Excellent. Oh, look, it's the same speaker in the walkie-talkie kit as in the doorbell. One of these little sort of 1-inch mylar speakers with a sort of transparent plastic cone. Now, something else I've been keen to do is to demonstrate a linear feedback shift register. And I've been building linear feedback shift registers using NeoPixels and the PIC. But to be honest, you can't really see how the circuit operates. So I'm going to show the LFSR in a different way. I want to show it using actual circuitry. So I want to do it with shift registers. These are the HC595s and little red LEDs. So let's just hook this up now. POS must be that end and neg will be that end. Now I've got to be careful here. I can't put 9 volts on this because I didn't put any current limiting resistors in the LED, so 9 volts would blow everything sky high. So this has to run on 2.4. That should function. Press the button. Yeah, so this is a shift register where you can enter data by pressing this button, and then that data just runs down the line. So a single bit, or 2 bits, or 3 bits, and the data runs down the line. Now the idea will be to hook up some exclusive OR gates, monitor some of the outputs on here, and then feed that back into the input. So yes, I'm going to do the LFSR using real components, schematics, diagrams, the works, so that we can see how it works. And the linear feedback shift register is such an interesting fundamental circuit and highly relevant because it's used in encryption and decryption systems. So it's highly relevant to the internet and communications today. Now here's another linear feedback shift register. There's the 18-bit shift register, and these are the exclusive OR gates. But this is used for something entirely different. This is a little module which generates random digital signals, or random digital ones and zeros, and then puts them out as an audio signal. So this produces white noise. And that brings me to, yes, it's the vocoder. Look, there's cobwebs on here because it's been hanging on the wall and I haven't done anything with it. So the vocoder only got this far. 2 boards, I think, I can't remember what these are now. Oh, I think they're tone generators, that's right, for generating just fixed frequencies. There are 2 tone generators. Well, the white noise generator fits on here somewhere. So this is an audio project from the 1970s, but just fascinating, and I want to get back into this big time. So I've ordered some more of these. These are these little surface mount containers with the little spring-loaded flip-up lids, but they're absolutely perfect for through-hole resistors. So I've done 1, the 11K resistors. All the rest are still in this plastic case, which I got from Lidl, but I bought all the resistors for the vocoder. I mean, look at them all. Pretty much every value you can imagine. Oh, well, I don't want to pull them all out, but they're all in there. Some more NeoPixels this year. These came from Alice. This was a sticky back strip. Can't remember where that came from. And these have just been sent in by icstation.com. So thanks very much to them. Now this is a set of concentric rings. It doesn't look like they're connected in any way, so that each ring is fairly independent. And I think these bridging points are designed to break off fairly easily. But whether or not I use this as concentric rings or just individual rings, probably leave them concentric for the time being. I think that'd be more fun. Now I am toying with the idea, and this is perhaps a little bit crazy, of doing something with the Z80, because the Z80 was my great love of the 1980s when I built my first computer, starting in 1983, I think it was. So this is a Z80 module that I built on Vero board using this sort of rat's nest hop across wiring technique. It's all a bit dusty because it's been hanging on the wall for many years, but I did wonder how simple you could build a Z80 demonstration board, not even using RAM, not using any peripherals. This is a counter timer, that's a UART, and that's a PIO, which is a parallel input output, because these microprocessors didn't even have ports. You had to wire a port chip like this, so you can see there are 2 8-bit ports on there, and you had to wire that onto the common data and address bus. It was all a bit different back then. Also, there was no built-in clock, so you had to build a clock circuit, you had to build a reset circuit. I think that one is reset. Some address decode here. There's another clock circuit there for the UART, because you need a different frequency for the UART. So fascinating stuff. And with a microprocessor, you can see more of what's happening than with a microcontroller because a lot of it is external. And then, of course, there's Muppet. Oh, Muppet! What am I going to do with you, Muppet? So this is my maximum power point tracking solar charge controller, MPPT. I added the U and the E in to give it a silly name. So let's take Muppet out into the garden and see what we can do with it. Oh my God, look at the patio, it's covered in ice. Well, now the solar panels are doing fine. I mean, you can see from the shadow there that the sun, even in the middle of the day, is very low. But yes, we are getting some sun. That's good for Muppet. But this isn't quite so good. Frost and ice. I mean, if I can't sit on the lawn, then I can't really play with this thing. And that's the problem with Muppet. It's a highly weather-dependent project. And as I expect you know, the weather in the UK is crap. So what the Muppet really needs is the Mediterranean Workshop. Have I told you about my Mediterranean Workshop project? So there we are, just a few thoughts for the videos in 27. Shorter videos if I can, that's always difficult of course. More building of kits, more circuit fundamentals, analog, digital, microcontrollers, maybe even some microprocessors. NeoPixels, LEDs, flashing lights. It's going to be an exciting year. Cheerio.